Plug numbers in.
Okay, so what's another way we could say that? Say it. Yeah, so we can use the rate of change to identify the parent functions, but also what Dawson was saying by plugging things in, what is he talking about when he's saying plug numbers in? Plug numbers into what?
The parent function?
Y'all know what he's talking about?
So like,
In this parent inside parent function, if it was f of x equals x cubed, and you'll fill it in for x.
Okay, so she's talking about when we have that equation, we can, what's that mathematical word we use for substituting? Oh, for plugging in, sorry, is substituting. But, okay, so looking at this table, can somebody tell me how they determined what kind of function this was? What kind of parent function this was?
The first one?
Yeah,
Cube.
right, so how'd you know that?
You put it in where x is, so you'll be negative 2 raised to.
Okay, so instead of saying put it in, what do we say?
Substitute it in.
Okay, so we substituted what in?
Negative 2, where the x is at, and you just cube it, and you negative.
So what equation did you substitute that into?
F of x equals x cubed.
Okay, so what Mikhail is saying is did you start with this?
Mm-hmm.
So how'd you know you could start with the x cubed? Were you testing out equations and see?
Mm-hmm.
Okay, so I guess this is another method we could use is she knew the equation for a parent function, so we're gonna test these input and output values in it to see if it works. And that's what you did, right? Okay, so what she was saying is if we substitute in a negative 2 and cube it, what do we get? Right. And so, was there anything else that you wanted them for the
Parent function?
do what?
Wait.
Yeah, parent function, like,
Just remember, you can't just test one number. You do need to test one or two of them.
right, because remember you are looking, well, that when you're trying to identify the parent function, but remember we want to test all the values when we're looking at transformations too.
hmm And then, again, graphing is a very efficient way to do it. I think there's even graphs, a coordinate grid on the bottom of that paper that you could have used to graph.
Does the TI Inspire have a function where you can input points that graph on there? Oh, I guess you would do that through the
Yes.
list or through the tables.
You can, or you can do it through, there's an option to put points, but I told them I would just do it by
Okay.
hand. It's going to be
Okay,
much
I think
easier to graph by hand than trying to
Okay.
do it on the calculator. Yeah.
And then there was another question.
Yeah. And I saw a handful of us on this one. Very few of us actually responded. Guys, I know that we didn't do a ton with these tables yesterday, but yeah, that's what I was wondering. Yeah, can you go back to the table real quick, Ms. Courtney?
Yes.
I need y'all to look at this again, because I'm not asking about the rate of change here. For transformations, we're looking at what's going from the parent function to the transformed function. So you need to look at the parent function. What's happening to every x value to go from parent to transformed?
They subtracted by 4.
It's being cubed. That's what you asking?
No, we're looking at transformations. Transformed function 1.
So I think the first question asked what was the horizontal change from the parent to the transform. So we're talking about that horizontal change. What do we need to look at?
The x values.
Okay, so we're looking at how the x changes. How does the corresponding coordinates of those x values change from the parent function to the transformed function?
Negative 4.
Okay, so Omar, what does that mean if the x changes by negative 4?
Your X value gonna change.
you were here yesterday, right?
Right, but how is that function going to transform?
Because the x to the next x is negative. It's 4 times.
No, right. You're right about it's moving forward, but what does that negative 4 or that minus 4 do to the
It's a
parent function?
horizontal translation
Okay, in what direction?
to
Right.
left. To the left. No, to the left. To the left.
It's gonna be to the right.
What do you think, Kyle? Which way is it going to go?
What?
It's
To
negative.
the right.
If it's negative, maybe it's gonna swap signs.
You just said
So why
to
do
the
you-
right.
So why do you think it's going to go to the right?
But why are you on me when she said the same thing?
You just said to the right.
Alright, Anthony.
So why is it gonna go to the right?
I'm just asking.
Cause like, it's a horizontal translation.
It's going to the left.
And it's subtracted by 4.
Okay, so we start at, if this first x coordinate starts at -2, and then we move 4 units over to -6, which direction did we move?
Left.
Left.
Okay, so when we have, guys kind of remember, like when we're moving, you said the x changed by -4. What do we have to be careful about when we're dealing with horizontal transformations?
Well, I'm the only one that changed. The same.
Right, but you said I was gonna go to the right. I'm going to the left.
Oh, the inverse?
Right, we have to consider the direction. We have to use the inverse direction.
I will point this out. I think this is where some of the confusion is here. We didn't get to talk about this a ton. It's the inverse in the equation, and only in the equation for horizontal transformations. But to go from -2 to -6, think about a number line. -2, your -6 is going to be over here, right? Do I have that backwards for you? Yeah. So here, and there's -6. Is that to the left or to the right?
That's to the left.
And that's what Miss Courtney was saying.
But I thought when it's anything, you're supposed to swap the sign.
That's what I said. In the equation is where you're going to have the inverse.
So when you write, if it's a horizontal translation to the left or the right, you wouldn't write right, you would write left.
I mean, if you go from -2 to -6, it's to the left.
That's what I'm asking.
And then when it goes into the equation, you're going to use the inverse operation. It's only within the equations that we deal with the inverses.
I guess what I was saying, just to, I guess, clear that up, what I was saying about the inverse here is the change from -2 to -6 is you're subtracting 4. So when you look at that change, and you're asking yourself like what direction that would be, I guess that's what I was saying is you take the inverse of that negative. Like looking at this, you would think you'd be going to the left 4, right, because of that negative. But you know when you put this in the equation, because when you have that,
Then
the
you
print,
change it.
right, because that's when you're looking at going to the right. So I guess I was just trying to make that connection without, but I skipped over it a little bit. Okay, also we gotta look at the vertical change in this table too. So how does, what is the vertical, 1, what transformation is occurring, and 2, by like how much?
Wait, huh?
What other transformations occur from this table?
Vertical reflection.
Okay, so why are you saying vertical?
Because the y changes.
Okay, so how is this y changing from this -8 to this -4? Okay,
1/2, or times 1/2.
okay, so those are both ways we can get from -8 to -4. So let's check these other points to see if that's consistent. So going from -1 to -1/2, what do we do? Well, what did we do the first time? What did y'all say? Times. Okay, is that consistent in the second set of points? Did we multiply this times 1/2 to get that?
Oh, so it's gonna be a vertical dilation.
But guys, I'm asking, was that consistent?
Yeah.
Okay, and then and then from 1, what did I multiply by to get 1/2?
1/2.
Okay, so then what kind of transformation do I have?
Vertical dilation. Multiplying by 1/2.
Oh, okay.
So how do we know that it's a dilation, guys?
Because it's not-
Cause it's
it's
multiplying.
multiplying, baby.
Right, because that operation of the multiplication, and what were you gonna say? But it's what?
If it was a reflection, it would be multiplied by negative.
Right, so if it was also a reflection, we'd have that negative in there too. Okay guys, so we are gonna start with that page y'all already have out, on that side.
Make sure you have those transformations written out on there, because in order to write the equation, we're going to take the parent function and put it together with the what? Transformations. Remember, we got to take the parent function, put it together with the transformations. So we're going to get you started. We talked through the transformations. Now we're going to write the equations in our small groups and come back together soon. But yeah.
So just real quick, our objectives today are, I can create equations of transform functions from tables and graphs. So that's what we're doing today, is focusing on making these equations from the tables and graphs, and then I can identify the rules for a function, for which a transformation is represented graphically, tabularly, or an equation. So, oh wait, we're not starting with this one. We are starting with this one, right?
Mm-hmm.
Okay.
So,
Okay, guys, so basically we're going off of, oh, did you want to tell them, get
It's all you.
started? Okay, so we're just going off of what you guys just started looking at for the bell ringer. So what we're doing is creating the equations from the table, okay? So I guess the way this is structured is each transformed function is the transformed function of the same parent function. Does everybody understand? Does everyone see what I'm looking at on their paper? You see transform function 1, 2, and 3. Okay, those are all from the parent function. So when you write the equation for transform function 1, it's coming from the parent function. When you write the equation for transform function 2, it's coming from the parent function. It's not coming from the previous one. So every time, which, you know, Mr. Kinney said this before, we always go back to the parent function when you're writing your equations to represent these transformations, okay? So, looking at this, what's the first thing you need to do one of the first things you need to think about when you're looking at a table of a transform function? Say that again?
The horizontal and changes.
Okay, but before we even know if there's horizontal and vertical changes, what do we need to establish first?
A parent function.
Okay, right, we need to understand what that parent function is to even be able to know, to be able to look at those kinds of changes in the numbers, okay? So kind of keep that in mind as you're going through this, make notes of the transformations, you know, because remember, you have, you're making,
We need Kylie Hyde to report to the computer lab for work keys.
she's on her way.
so remember, oh, I lost my train of thought.
You were saying that they need to write out their
Yes,
transformations?
write out your transformations because, remember by writing the equation, you're making this claim that these transformations occurred, but how do you justify that? How do you justify making a claim?
Evidence.
Right, okay, so that's what we're practicing as you're going through these problems. So, we're gonna spend about probably 15 minutes or so on this. Me and Mr. Kenny are helping you guys out, or supporting you as you work together in your groups, and work on that active collaboration. And yeah.
Let's get to work.